Okay, so one of the many privileges of being in honors chemistry is the opportunity to get to memorize the common polyatomic ions. Now, there's several patterns that is present within this chart that I'm going to help you identify in order to help you out. I'm going to start first with talking about the phosphate. Okay, as you saw in your reading, some of the common endings for polyatomic ions are ite and ate. So we have sulfite, sulfate, phosphate, nitrite, nitrate, and also chlorite. Now what we notice about ites and ates is they actually have the same charge. For example, nitrate both have -1 charges, but the difference is that the ate is always going to have one more oxygen than the ite is. So you see that this is true for nitrite and nitrate. The ate has one more oxygen. Chlorite and chlorate, the ate has one more oxygen. Sulfite and sulfate. Okay, so a good way to remember those is if you know your ites, you know your ates. You just take the ate and subtract one oxygen off of it and you get your ite. Okay, so that's a good little trick there, knowing ites versus H. Another little trick is by actually looking at when there's a hydrogen in front. Dihydrogen, hydrogen sulfate, hydrogen carbonate, hydrogen phosphate. There's a little trick for this as well. For these, what happens is if when you add a hydrogen in front, you'll notice we're now going into the -2 charges. It's just a hydrogen in front of phosphate, HPO4, and the only thing that changes is the charge. The charge is now a -2. When we add 2 hydrogens, the charge goes down by 2. It's H2PO4. Now the charge is a -1. Okay, for hydrogen sulfite, it's sulfate, SO3 with a hydrogen in front, the charge gets reduced by 1. HSO4 is hydrogen sulfate, it's sulfate with a hydrogen in front of it, charge is reduced by 1. So anytime we put that hydrogen in front, same thing with hydrogen carbonate, we reduce the charge by 1. Okay, so if we're looking at it, a good amount of these we can actually memorize. If we know sulfate, we can figure out the rest of them. If we know phosphate, we can figure out the rest, nitrate, chlorate, carbonate. So that really cuts down the amount we have to memorize. There's a couple others that stand out or kind of stand alone and it can be a little bit easier to memorize. For example, ammonium is the only cation polyatomic that you're being asked to know. It's NH4+, so that in a way stands out. Also, there are some that actually sound like their name or represented very similar to the name. For example, cyanide is CN, which is actually contained in the name. Hydroxide sounds just like that. Hydrogen and oxygen together, OH negative. Hyperchlorite and perchlorate kind of get bracketed into here together. If you know chlorite and chlorate, you can figure those out. And then the other one here is chromate and dichromate. Also sound very similar as well if you can group them. There's only a few here that really kind of stand alone and can be more challenging to get to know, and that's acetate, permanganate, oxalate, and silicate. And I think probably the best way to approach these for memorizing is to create flashcards or to do lots and lots of practice with them to really commit them to memory. I hope those strategies are helpful, a way to approach memorizing it. Flashcards are always good, creating a chart, trying to recreate this chart as much as possible, writing it out, and quizzing one another are also all really good strategies. If you have any questions on how to memorize these or you need someone to quiz you, please let me know, and I'll see you in class tomorrow.